So let's talk a little bit more about stars. Okay, I love this poem right here. This poem is a play on a classic poem, which is called Twinkle, Twinkle, Little Star. So we all know the classic version of this, right? Twinkle, twinkle, little star, wonder, wonder what you are. And that's all well and good. But here's the problem with it. We kind of know what it is, right, at this point. So this is kind of an updated version of that. So let's go through it and try to apply what we've known. I want you to think about this as you go through. What's the most common color of star? And it says to here, use that color to write and how old in billions our star will be when it dies. So how old will the sun be when it dies? Try to think if you could figure that out as we go through it. So here we go. Twinkle, twinkle, little star, I know exactly what you are. Opaque ball of hot, dense gas, million times our planet's mass. Looking small because you're far, I know exactly what you are. Opaque means you can kind of see through it, but you kind of really can't. So you can sort of see through it. Anyway, fusing atoms in your core, that's pushing them together, fusing them together. Hydrogen, helium, carbon, and more. With such power you shine far, twinkle, twinkle, little star. Bright when close and faint when far, I know exactly what you are. Smallest ones burn cool and slow, still too hot to visit though. Red stars dominate by far, twinkle, twinkle, little star. Largest ones are hot and blue, they supernova when they're through, then turn into black hole or neutron star, I know exactly what you are. Our sun's average as stars go formed 5 billion years ago. Halfway through its life so far, twinkle, twinkle, little star, forming from collapsing clouds, cold and dusty gas and shrouds, spinning, heating protostar. I know exactly what you are, twinkle, twinkle, little star. Whew, we made through it. Okay, so 2 questions I had for you was what's the most common color of star? That is red. Red is the most common color of star. We can't see all of them because they don't shine as brightly. So there's a lot out there, but they have to be huge or closer to us for us to see them. So that's why we don't see nearly as many of the blue shifted ones. But it says, how many billions of years will it take for our star to die? Well, it says our star formed about 5 billion years ago, and it's halfway through its life so far. So it's got about another 5 billion years left. So it'll be roughly 10 billion years at the end of its life. And then what happens? Here's a life cycle of a star. Now, a couple different possibilities that I can go through. I'm going to start over here. We start with a stellar nebula. Remember, this is the stellar nursery where these stars get created from. Okay, now it can either form an average star, just like ours. We have a perfectly average star. Nothing special about ours. The only thing that's special is because it's close to ours. It's ours. It's special to us, right? It's everything to us. It's where we get all of our energy from. But in terms of the size comparison to other stars, really not that special. So let's see what happens to our star. Well, over time, it then turns into a red giant. When will that happen? We'll talk about that later. Finally, after the red giant is done with its red giant phase, it changes into a planetary nebula, and then it'll just be this little ghost or remnant of what was once there, sometimes called a white dwarf. Really, really, really tiny, really faint. You would never be able to see them with the naked eye unless it was really close to you. What about the massive stars? Some of these stars are, when we call massive, I believe they're something like a million times bigger than our star, let's say. So really big. Maybe not quite that big, but really big. Now, when they're done, they turn into a red supergiant, right? So this is a common thing that happens near the end of the cycle of stars. Now, because the red supergiant is so big, so much mass, it actually becomes unstable and it explodes into a supernova, sending its chemically enriched guts all over the galaxy. You do not want to be near it when that happens. So hopefully no stars near us, close enough to us, would supernova and then blast us with that radiation, because that would be a bad day on Earth for sure. Now, 2 things can happen afterwards. It can either change into an incredibly dense neutron star. It's like the densest stuff that you can even possibly imagine. Or black hole, which I'm sure you've all heard about, and it's pretty exciting. So let's go down to the life cycle of our sun, of the sun. So we start out about 4.5, 5 billion years ago, roughly. That's our birth. Then we have 1 billion, 2 billion, 3 billion, 4 billion, and then somewhere in between 4 and 5 billion, that's where we are now. Now, over time, the sun is it's over a really long period of time. If you've heard about global warming, the sun getting hotter has nothing to do with global warming as far as our current experts are showing. But in billions of years, eventually, gradually, the sun's going to get hotter and hotter and start to expand just a little bit until at about 9 to 10 billion years, it will expand into what's called a red giant phase. Red giant phase is so much bigger than the current phase. It will expand. It will engulf the orbit of Mercury and Venus and possibly Earth. If it doesn't engulf Earth, it will be such a it will be so hot and so close to us that nothing can survive that is on Earth. So here's a little poem or a little phrase that I love. Now, I know we're talking about the death of our planet, and that is a big idea, potentially a scary idea. Just know that this isn't projected to happen for another 5 billion years. So most likely at this point, either humanity will not be here or our distant ancestors will be, and I'm hoping that by then they can figure out a way to colonize beyond just planet Earth. Otherwise, it's been a good run, humanity. So let's talk about it. After the Earth dies, some 5 billion years from now, after it's burnt to a crisp or even swallowed by the sun, there will be other worlds and stars and galaxies coming into being, and they will know nothing of a place once called Earth. Ooh, spooky. I love that phrase. So here's another image right here. The sun as a red giant. So this is what it looks like now. And by comparison, this is what it will look like when it expands. And in 5 billion years, the sun will expand and engulf our orbit as the once charred ember that was once Earth vaporizes. Have a nice day. Another astronomer that I really like, Neil deGrasse Tyson. So let's look at the size of our sun. This is what we're used to. So this is the size comparison, roughly compared to Earth. That's kind of like how big it would be in our horizon from there. It's bigger the closer you get. So from Venus, it looks bigger in the night sky, in the sky, I should say. From Mercury, look how much bigger it is. And then gradually, as you get further and further out, now from Uranus or Neptune's perspective, it barely looks that much different than any of the other stars. It just has a much orange or yellower color there. Here's a video about the background of the birth of the solar system. Very interesting. And next, we'll talk about our planet.